All right. So the first question here says in a sale, the normal price of a boot is reduced by 15%. The sale price of the boot is 272,000 pounds. It says work out the normal price of the boot. Okay. So could you give this question a try? Let's see if you have an idea. It's just like that percentage question that we did in the morning. Hello, Noah, are you there?
Yes.
Okay. So can you give this guy a try?
Yeah.
So what should we where at what point should we start?
100 minus 15.
Mm, okay. 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 We prefer that method. Okay. Let's see. So 100 minus 15, that would be 85. Okay. Yes, that would be 85. Okay, so that's 85%. So if we were to work that out, how will it look? 85%, that's 0.85. 0.85 times the normal price, right?
Yeah.
So that's let's say, let P be the normal price. So times the normal price will be equal to 272,000. Okay? So the question now is, what is P, isn't it?
Yes.
So what should we do to both sides to find P?
Divide them by 0.5. 0.85.
Exactly, to divide them by 0.85. Okay, so can you do that on your calculator while I just write this down? Let me use the ink. Write it down. 272 0 0 0 divided by 0.85. Okay, okay. So P, what does your calculator say as a
Um,
final answer?
3 is 32000.
Three, two,
No, full zeros.
4 zeros, right? Okay.
Yeah.
Yeah, I expected that. So it has to be more than what is in the question. Excellent. So we're on the right track. That's the answer. Okay. All right. So if you like this method, it's cool. I mean, it will save you some steps, but then you have to tell us how you got uh, uh, 0.85. So maybe I should write it there that we started by saying 100 minus 15 because it's a decrease, a reduction. Okay. So that gave us 85%, and 85% is as good as 85 divided by 100, which is 0.85. Okay. All right. So are you good with this method?
Yeah.
Okay. So you have to know that if you're using this method, then even when it is an increment, you should also stick to the opposite, right? That would be addition instead of subtraction from 100, isn't it?
Yes.
Okay. Okay, no problem. If you're cool with this method, that's fine. So I'm moving on then. Okay, so yeah. So don't worry, you see that I will be, because we are seeing similar questions, okay, that to the ones that we have done both yesterday and earlier this morning. I'll be asking you more, to participate. Okay, so how about this one? We are to solve this quadratic equation. Okay, so how do we solve it? Can you remember how we solved a similar question to this?
Um,
What was the first thing we did?
pardon?
Okay. What did you say? Do you have any idea?
I'm trying to. I need to find the coefficient of x, right?
Okay. So yes, we'll take note of some of the coefficients. But before you take note of the coefficients, there are some things you need to take note of. Firstly, um, you need to first check the coefficient of x squared and confirm that the coefficient is 1. So as in positive 1, okay? So check coefficient of x squared. If it's positive 1, like in this case, by that I mean the number that's multiplying x squared. So since, when it's 1, it looks like there's nothing in front, but we all know that there's an imaginary 1 there. And when there's no sign in front of it, we also assume that the sign is what? Positive, a positive 1, okay? All right. So in this case, we are good, and it's a positive 1. So what's the next thing we should do? Like you said, we should look at the coefficient of what? X. And what are we going to do with the coefficient of x? Do you remember?
Um, Add to the -7.
No, okay. So maybe it's trying to come back to you, but what we do with it is different from just adding. We'll ask ourselves a couple of questions, actually 2 questions. Okay. The 2 questions are these. Number one, what are 2 numbers such that when I multiply them, I'll get -18. Okay, so -18, that's the one that ends the last number that doesn't have any x attached to it. Okay, please take note, we're taking it with the sign in front of it. When you multiply, you will get that number. Then for the coefficient of x, when you add those 2 numbers, it should be able to give you that same coefficient of x. So this one answers the multiplication question, while this one answers the addition question. Okay, do you remember it now?
Yes.
Uh-huh. Okay, so this one is addition and this one is multiplication. So let me just write it here so it's a reminder. Okay, so now that we're good with this, let's start guessing. Now, when I say, when I say you should guess, your times table should come to your aid now. Okay, So think about all the numbers that when you multiply them, they will give you 18. That's where my mind is going right now. What are the numbers when you multiply them? Start from your 2 times table, 3 times table,
9,
6 times table. Those are the things we're looking for. So the first set of numbers, yeah?
9 and 2.
Exactly, 9 and 2. Now, be careful. We are looking for two numbers such that when we multiply them, we'll have minus 18. So 9 and 2, but it has to be a particular order. What I mean by that is, for us to get minus 18, the minus sign has to be on one of them, isn't it?
Yes.
Okay, good. So which one should the minus sign be on? That is what the sum will help us to do. So the two possibilities before us are minus 9 and plus 2, or 9 and minus 2, right?
Yes.
Okay, so do you know how we're going to get the right one? Simply check the addition part. Whichever one gives us the addition part, that's the one that will solve the problem for us. Now, did you notice something? Because of your, you were quick to identify 9 and 2. It's possible that another set of numbers could have come to your mind first, like 6 and 3, isn't it?
Yes.
It's also possible that the first set of numbers that could have come to your mind are 18 and 1. Those are possibilities. They are all possibilities, valid possibilities. But the good thing was that you started with 2 and 9. That helped you to go straight to the point. Well, and it's fine. It's perfectly fine. You're not always lucky to get the first pair and get it right. So it's good that you were able to quickly identify. Now we have identified it. Let's now let's weed out the ones that need to be weeded out. Okay, so let's try this. Minus 9 plus 2, what would that give us? What would minus 9 plus 2 give us?
Minus minus 7.
Exactly, minus 7. Then just for fun, let's find out what 9 plus minus 2 will give us.
7.
7, thank you very much. Okay, so you know what happened, right? The minus sign superseded the plus sign, the addition sign. So it was just as good as 9 minus 2, which gave us 7. Okay, so it's obvious that this guy is our guy, isn't it? This is what we need, isn't it? Because it's minus 7 that we need. Please don't forget, the signs are very, very critical. Okay, the signs in front of the coefficient, very, very critical. If not, this question it's a very easy question to mess up, and it's very easy to equally get it. Okay, so now we have gotten the two numbers. What are we going to do next? Simple. Replace the guy in the middle. That's all. So this is what we will now have. Because of this thing, I can't use the text box, so I'll have to write it because of these guys, the powers and all that. So x squared. Now you can just put it exactly as it is. Anyone, whichever one favors you is best. You can, somebody might be saying, should I put the 2 first? Should I put the minus 9 next? Anyone that comes in handy will be cool. Okay, so now I'm thinking. Okay, yeah, let's just flow. Minus 9, because it looks like minus 9 comes first in this. Please don't forget the x, okay? And then plus what? Plus 2x. Okay, so I hope you know why it is mathematically correct to do this. Are you good with this? Why we have this as our next step?
Yes.
Okay, perfect. All right, so let's go ahead and factorize. Now, can you see the aim of doing this? We now have 4 terms. We can group these two together and factorize. and we can group these two together and factorize. So let's flow. So what's common between this and this? What
X.
do you see in common? X, thank you very much. We can't do anything with 9 because 9 is not here. So let's put X outside the bracket and open our brackets. If you factorize X from X squared, you'll be left with X, isn't it?
Yes.
And if you factorize X from 9X, you'll be left with what? 9. All right. Okay. So anytime you're in question about whether you are doing it correctly, just quickly do a mental calculation. Let's try and see if we multiply this guy back, whether we'll get this. You see that X times X is X squared. X times 9 is 9. X times minus 9 is minus 9X. So it's correct. Okay. So moving on to the guy on this other side. What's common between this and this? What do you see in common? I can see 2 there,
Yeah.
right? Yeah. So let's bring out 2. So, and when you're bringing out 2, you have to be conscious of the sign. So, and then let's ask ourselves, if I bring out 2, so this is what's going to happen. Don't forget to put your bracket. If I factorize 2 from 2x, I'll be left with x, isn't it?
Yes.
Good. And then if I factorize 2 from minus 18, I'll be left with minus 9. Do you agree with that?
Yes.
Because 2 times minus 9 is minus 18. So it will give us back minus 18. So we are good. Now, what's one sign you will use to know that you are on the right track? Simple. The contents of this bracket are the same as the contents of this bracket. Once they are the same, you are good to go. If they are different, you are not good to go. Okay? You have to make sure they are the same. All right. And that's going to be by your choices of what's common. All right. So let's move on. Since this and this are the same, we can further factorize by doing what? Bringing them out. So that would now be x minus 9. Okay. That's common. Keep it in its own bracket. Now, if I factorize x, the whole of x minus 9 from x times x minus 9, guess what I'll be left with? I'll be left with x, isn't it? That's this x. Look at the plus sign here. Go ahead and put your plus sign there. If I factorize x minus 9 from 2 times x minus 9, I'll be left with 2, isn't it?
Yes.
And that's it. We're very close to the final answer. Now, there's a mathematical principle that says if something times something gives you 0, then either this guy is 0. Remember, our whole lives in mathematics thrives on principles. Okay, so either this is 0, or let me take this to this side, or this x plus 2 is 0. One of them must be 0. Okay. And we usually use or in between. Okay, so this or this. So let's solve it now. Now remember, you're looking for x. Okay, so what should I do to both sides? What should I do to both sides? Minus 9 and 0. I should collect like terms, isn't it? That's another way you can think of it.
Yeah. I moved the 9 to the
So
right.
yes, exactly, correct. So that's going to give me 0 plus 9, isn't it?
Yeah.
And 0 plus 9 is 9. So first solution for this question, remember the question said solve. And anytime an algebraic question tells you to solve, they're asking you to find out the value of the unknown. So you must, once you get here, you have succeeded in doing that. Now that's not all. You have to do the same thing for this other guy. But because of space, let me move it to this side. let me draw a line here and move it to this side. So let's do x plus 2 equals 0. Okay, so x plus 2 equals 0. The same thing you did for minus 9, moving it to the other side. If I move plus 2 to the other side, it will become what? Can you guess? What will it become?
Mine -2.
Huh? What did you say?
-2.
Minus 2. Yes, -2. Okay, so just for, steps wise, we'll say 0 minus 2, which we can conclude as well. X equals -2. Perfect. So those are our two answers. And usually, quadratic equations have two answers, okay? Always. So either x equals -2 or x equals 9. Those are the roots of your quadratic equation. Okay, so are you good with this guy? Can we continue?
Yes, yes.
Now, it will really be nice, right? If you can present your working like this, okay? Don't try to skip any step. You see that there's no way you won't get your full marks. Yeah. Well, yeah, they said total for question 27 is 3 marks. You can just look at the essential steps that you must do. Okay. At least show that this part is a guessing part. This is where you're doing your guessing, the right hand side. Add and multiply. You don't have to write, show all this. All this is happening in your mind. The add and multiply side is happening in your mind. The side that you must show you're working from is where you have x squared minus 9x plus 2x minus 18. You must show that working. Okay, then follow it through the process and go. At some point you can skip, for instance, the x minus 9. Just go ahead and put your x equals 9, and the other one x equals -2, and you're good to go. All right. So I think we should just move along the way we did with the other ones. If there's anyone that you solved and you're confident with your level of understanding in those ones, we can skip it. Is that fine with you?
Um,
I
yeah,
don't know. Are you there?
yes,
Okay. Did you hear my question?
yes. Can skip it.
Okay. Okay. Good. Okay. All right. Okay. Good. So which one? Should we go ahead with these guys or?
No, that's fine.
Okay, I should skip this guy.
Yes.
Okay. How about this one? ABC is a right angle triangle. Work out the length of BC.
Yeah, you can skip that one.
Okay. All right. How about this one? Here's the right angle triangle, 8 millimeters, 10 millimeters. The shaded shape below is made from two of these triangles. Work out the perimeter of the shaded shape. Um, and give your answer correct to three significant figures. Can you handle this one on your own?
Um, yes.
Okay. So if you were to solve this particular question, what would you do? Just give me an idea.
Um,
What would you do?
E squared plus 10 squared equals x squared.
Okay. 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 So that's Pythagoras theorem, right?
Yeah.
Now, So let me ask you a question. Can you see there's a small issue here? And I'm not too sure if this question took that into perspective. See what is going on here. The perimeter of this shape is the whole length from here all the way down to here, all the way down to here. These guys, you know, they are kind of covered. You already know them. All the way down to here, right? These ones, you already know them. The real problem now is here. I hope you know that there's an issue here. We don't know this length from here to here. Do you know that?
Yes.
Ah, that is a big issue. If you were to find out that, how do you think we should find it out? Because honestly, that's just the problem, really. They're asking us for the perimeter of a shaded shape. And, you know, yes, from here to here, your Pythagoras theorem will give that to you. But the problem now is this place. That's where the issue is. So that's what I've been thinking about. And then I think there's a possibility that this question, because I mean, come on, this guy said, work it out. So that's now the confusing part. If they want you to work it out, that means they're expecting you to do some calculation, not just use, what do you call it? Um,
Pythagoras.
um, yes, no, you're using Pythagoras. Pythagoras is working it out. But I mean, using maybe your math set or stuff like that. There's something more to this that meets the eye. I'm trying to see if I can figure it out. Okay. Okay, you know what? I just saw something now. I just saw something now. You remember that from here to here is 10 millimeters, isn't it?
Yes.
Good. So that means that from here, even though it's not part of what we're calculating, from this place to here is also what? 10 millimeters. From here to here. Did you see that?
Yes.
Good. So whatever you get as your hypotenuse, that's from here to here, right? Is I'm expecting it to be more than 10 millimeters because that's the reason why this place is longer. Did you get that?
Yes. Yes.
Good. So remember this 10 millimeters is on this other, it's on this other right angle triangle, not this one, not this particular one. No, not this one. It's on this one. So take note of it. This other guy, his own hypotenuse goes all the way from here to here. So because of that, I know that the hypotenuse will be longer than the 10 millimeters. So what are you going to do? You're simply going to say the hypotenuse from this place to this place minus 10. That's what will give you this small side. So that's good. So what I'm trying to say is that this small shape that you're seeing here is hypotenuse. I don't know what is the value. You can calculate it. Hypotenuse minus 10. Do you understand what I just did back there? So take a look at it. Do you understand what I did back there?
No, I'm a bit confused.
Okay, let me take it again. Now remember, the hypotenuse starts from here. Just look at the markings. I'm marking from this place all the way down to here, isn't it?
Yes.
Good. Now, we took one of these triangles and put on top of the other one. So the side, the 10 millimeter side somehow is resting on the hypotenuse of this other triangle. Let's call it triangle 2. Okay, so this is triangle 2. This is triangle 1. Let's call it triangle 1. Okay. Okay.
Yeah.
So triangle 1, its 10 millimeter side is resting on the hypotenuse of triangle 2. Did you get what I just explained now?
Yes.
Good. Now, I'm saying, because we all know that it's a fact, a mathematical fact, the hypotenuse of a right angle triangle is the longest side in that right angle triangle. So what that means is that the hypotenuse here will be more than either 8 millimeters or 10 millimeters. It will be more than it. And that is that's exactly is expected. I'm not surprised that that happened. That this guy from in triangle 1, from here to here, okay? Look, just I hope you can see what I'm marking. This place to this place, okay? From here to here is just 10 millimeters for triangle 1. Now for triangle 2, from, I don't know how I'm going to do it now to differentiate it. Okay, but you understand what I'm trying to say. The hypotenuse for triangle 2 goes beyond this place. All the way, it goes all the way to this place. Did you get that?
Yes.
Good. So this small distance that we couldn't figure out back then, I was saying that would be the major issue for us. It's not really an issue because we're going to get it now by saying the hypotenuse for triangle 2 minus 10. Where did I get the 10 from? The 10 is from the side, remember this is the side of the triangle 1 that is sitting on the hypotenuse of triangle 2, which is 10 millimeters, isn't it?
Yes.
Okay, so do you now understand how I got that, that's how I came by that expression?
Yes. Yes.
Okay, okay, so you're good with it, right? I can leave this question for you to finish up, right?
Yeah.
Okay, so thank God because honestly, I was just asking myself, how would we get that small, that small place? But I now saw that, oh, it's easy to get if we just understand what's really going on in the shape. So let me just put the calculation here for HYP. HYP is going to be simply equal to square root of 8 squared plus 10 squared. So your calculator can do this for you. We're not even expecting whole numbers. So that's why you see where it says here, give your answer correct to 3 significant figures. So we're expecting it to be like that. Okay, so I'm moving on. All right, so we can move on, right?
Yes.
Okay. Okay, so this one is a graph. It says draw this. I think you are good with graphs. Of course, filling up the table shouldn't be an issue for you. Just substitute for values where they need to be substituted. Okay, so again, please just tell me which one, if we need to skip this question. Should we skip this one?
Yes.
Okay. All right. HCF. I believe you are good with this one. I saw what you did back there with HCl and LCM. So those ones are minimum. Okay, so let's see. These ones look like indices problems. Okay, let's quickly do them. C raised to power 5 divided by C raised to power 2. That's C squared. Okay, so remember the rules for indices. Let's just remind ourselves of the rules. X raised to the power of A times X raised to the power of B equals X. Sorry, my X looks like 2 at that point. X raised to the power of A plus B. Okay, that's for multiplication. Then for division, X raised to the power of A. You remember that time I told you that times and division were like brothers and sisters, and that when it comes to in terms of cousins, then you can say that multiplication and addition are like cousins. This is what I was referring to actually. Okay, so that's going to be A minus B. Okay, so can you tell me what would be the final answer for this guy?
C3.
Yep, C3. Okay, so that's C raised to power B. Now, I don't know if they will ask you for this kind of question to show your working, but I mean, I don't know, no. But if they ask you to show your working for any reason, then it's simple. Just, I mean, C raised to power 5 is C times C times C times C times C in 5 places, right? So if you really want to show your working, which I'm doubting that they will ask you for, it's more like proving the law. I don't think they will ask you for this, but let's just do it in case they say so. 1, 2, 3, 4, 5. That's C raised to power 5 all over C raised to power 2. That's C times C. Things will cancel, isn't it? This guy will cancel one of these guys. This guy will cancel one of these guys, leaving you with C times C times C. That's C raised to power 3. Okay. But I don't think they will tell you to do this because this is like the proof for these guys. Okay. Anyway, so moving on. The next question said D raised to power 4, all raised to power 3. The law for this one is X raised to the power of A, all raised to the power of B is equal to X raised to the power of A times B. Okay, so it's just saying that you should just multiply them. So for this particular question, this is going to be, if we follow what this law just said, it's going to be D raised to the power of what? 12, isn't it? Because 4 times 3 is 12, right?
Yes.
Okay. So let me put this guy in a box so that we understand that it's the law and not part of the calculation. Okay. Okay. So any question on this?
No.
No. Okay, good. Okay, let's go to inequality, one of our favorites. Okay, so for this one, I think they gave you the graph. They're not asking you to tell the inequality. You see, different flavors of the same question. Now, I told you, anytime you see that the circle is not shaded, it means that what sign is there? It's either going to be greater than or, sorry, it's either going to be less than or greater than. Now, how do you know which one is which? the direction of the arrow will give itself away. Very, very simple. There's no big deal about it. And for this guy, the arrow is pointing towards the right-hand side. So let me quickly erase what I don't need to see. I don't need to see this guy because the arrow is clearly pointing in that direction. Okay. Now, what are we going to do next? We will put our variable. The variable here is x. Please take note. It's not just any random variable. You don't just put any variable you like. It has to be the one that matches the letter that's there. And for this one, the letter is x. So x greater than. Now, what's the value where the circle is? Please take note. I didn't say it's not this one we're going for. It's not 5 we're going for. It's where the circle is. That's where it matters. And that is -1. So this is the answer to this question. Okay, so please, you have to take note of the fact that this graph, this inequality, this number line, sorry, doesn't look like this. It's not like those ones that we do that look like this. That had 2 circles and have 2 values. So something like -1 and then something like +3. No, it's not like this. It's not. Okay. If it was like this, then guess how it's going to look? So let me just wipe that up. If we had this scenario, then this was going to happen. Let me put it in a box because this is a different question altogether. If we had this scenario and this is your x, the graph is x, right? Then this would have been the answer. Of course, 0 will be somewhere here, my imagination. Okay, this would have been the answer. -1 less than x less than 3. Okay, this would have been the answer for this guy. Okay, now why is it like this? Because there are 2 circles and 2 of them are not shaded. Let's pretend one of them is shaded. Let's pretend that it's this one that is shaded. Then you have to put an equals to. Okay, did you get that?
Yes.
Okay, as if I knew. That's the next question. It says on the number line, show the inequality -3 less than or equal to y less than 4. So it's very simple, right? All you need to do is to, in fact, different people have different varieties of their own. Some people don't put this line that I put here. So if you don't put the line, then your circle will be hanging in the air like that. Now, did you notice that there's an equal to on the -3 side? So that means we have to shade it, isn't it?
Yes.
Good. Then, now, please, there's no requirement that the line must be a straight line. Okay. I don't know, but if you want to make it straight, well, this is just my best effort to make the line look straight. So it must not be a perfect straight line. Okay, so when you get to 4, make sure that you draw that circle and don't make it go beyond 4. If not, you are telling us something different. Okay, so this is perfectly perfect. Did you notice when the graph, the number line, the line on the number line has an arrow that is pointing like continuously, it means there's no end. That's the reason why that's the reason why the answer for this one was like this. But when you don't see the arrowhead, there's no arrowhead here. That means it's limited to just these 2 values. Okay, -3 and 4. Okay, so are you good with this?
Yes.
All right. Okay, so we proceed. Okay. So is this one something you can handle? Or you want
Yes.
us to take a look at it? Okay. Right. How about this one?
Um, no, I don't know.
Okay, let's look at it then. It says the incomplete table gives some information about the length of the planks of wood in Ben's shop. It says the total length of these planks is 92 meters. That means by the time you add up all the length of all the planks, you'll get 92 meters. It now says work out the number of planks of length 2 meters in bench shop. In other words, complete the table. That's just another way of saying it. So now, I know at first it will look daunting, but if you look at it very well, it's really simple. All you just need to do is to multiply the length of the plants by the number of plants. So for instance, the first one you have is 5 times 3. Let me use a text box for this one. So the first one you have is 5 times 3. Okay. Then we're going to say plus. The next one is 2.5. 2.5 times what? 8. Okay. The next one plus. Now, since we don't know the one for 2, let's use a letter. So we're going to say 2 times, let's use T. Or should we use another letter? Let's use D. Okay. Plus, the next one is 1.5. I hope you understand why I'm multiplying.
Yes.
Okay. 1.5 times a whooping 14. Okay. So we have next 1 times 10. 1 times 10. Okay. So here we go. Now, remember, all this is supposed to be equal to what? 92, isn't it? So we have an equation. All we now need to do is to just collect like terms. Sorry, we'll first get the values out. So thank God for, so those ones that are with decimals, let's quickly clear them off. 5 times 3 is 15 plus 2.5 times 8 will give us what? If 4 times 25 is 100,
20.
100 plus 100 will be 200, right? So that's going to be 20. Is that 20?
Yeah.
20.0, right? Okay, so the 20.0 is as good as 20. Okay. And then 2D. So 2 times D is 2D. Let's just put 2D there. Don't worry, we'll come for it. We'll come for it later. 1.5 times 14. 1.5 times 14. What would that give us?
21.
Did you say 31?
21.
I didn't hear you. I hope I heard you right. 31,
21.
right? 21. Okay. All right. Times. Okay. All right. So that's 21. Then next, 1 times 10. We all know that's 10. Easy, easy. Of course, we have 92 on this side. So when we collect like terms, so 2D will stand on its own, isn't it? And then let's add up those other guys before we move them to the other side. 15 plus 20 is 35, right? 35 plus, let's add, how should we do this? 35 plus 10 is 45. 45 plus 21 should give us 66. Is that correct?
Yes.
Okay. So 2D plus 66 is is equal to 92. And then you know what to do, right? What are we going to do next at this point?
Move 66.
Oh,
Yeah,
of
52
course,
minus.
you move to 66 to, yeah, 92 minus 66, isn't it? And that will give us what?
Um,
2D
26.
equals
26.
26. Okay. All right. So we're looking for D. What are we going to do to both sides?
Divided by 2.
Divided by 2. So at this point, I have to leave this guy and use the ink. So that's 26 over 2. Okay. And 26 divided by 2 will give me what?
13.
That's 13, right?
Yeah.
Yep. Okay. So that means D is equal to 13. That's the answer. Okay. Any questions on that before we move on?
No.
No, okay. Okay. Is this something you can handle?
Yeah.
You can handle it, right?
Yes, yes.
Okay, cool. Okay, how about this one? Pie chart and stuff.
Um,
I think, I'm not sure we have really seen questions on pie chart in all the ones we've done, right?
yeah.
Okay, so we should just do this one. Maybe we should just do this one. Okay, so it says the pie chart gives information about the color for each car in the car park. So we have black, white, and other colors. Okay, and it now says there are 135 black cars in the car park. It says work out the number of white cars in the car park. Okay, so they're clearly expecting to see workings. Okay, so let's do this. The first thing I would do, because they said the number of white cars, right? So the number of white cars should correspond to the angle that white cars occupies in the pie chart. So the whole idea of a pie chart is this. Angles are used to represent what numbers would represent in real life. That's just the summary of a pie chart. Okay, that's why it looks so nice. Everything looks, colorful, but it's really the angles that make it tick. Okay, so if I were to handle this question, if I were to handle this question, right, 135 black cars. So that means that, and if you look at for black cars, this, whenever you see an angle like that, that's 90 degrees. So that means that, now this is the implication. It means that 90 over 360. Why are we using 360? Because 360 is the total number of angles at the center of a circle. Okay, so 90 divided by 360 times. Now, did you notice something? They didn't tell us the total number of cars in the car park. They didn't. It's, if you look very well, it's not there. So let's use T, the total number of cars in the car park. 90 over 360 times T is going to be equal to 100 and what? 35, because that's the number of black cars. Okay, please take note. Where did I get the 90 from? Here. Okay, where did I get the 135 from? Here. And that's because it's for black cars. So I told you the secret of pie charts. Angles correspond to numbers. Okay, so that's just what I just did. Now, our job is to find T. I'm sure you're guessing, you should be able to guess now why I'm looking for T, because that's what's going to help me to find what the question is asking me for, to work out the number of white cards in the pack. So let's find T. We're looking for T, but before we find T, let's take some things out to make life simpler for us. 0 cancels 0. 9 goes in itself one time. And because we know that 9 times 4 is 36, we're left with 1 over 4. The T by itself is on top of 1 already. So it already knows its place, right? It already knows its place. T times 1 is what? T. And 4 times 1 is what? 4. So you're left with T over 4 equals 135. So what would T be if you are asked to find, if you are asked to get the value of T? What will we do to both sides to get T?
Or multiply by 4.
Thank you very much. You multiply by 4. Impressed that you are getting this. You've got this point. So 135 times 4. And what would that give you by our
540.
by our 540? Was that what you said?
540.
540, right? Okay,
Yes.
540, yes. Okay, so let's hit the road now. Now, it's not really the total number of cards they want, but because they asked us to work out the number of white cards in the pack, we can easily come now and say 80 degrees. You just do the same thing that you did for the black cards, but this time you're using 80 instead of 90. 80 over 360 times. Now, instead of saying times T, we already know what T is. 540. So it comes to us quite easily. Don't forget to put your over 1 so you know where things are. And I think we're free to do some canceling here. This can cancel this. Okay. Okay, so what else can happen here? 9 can play ball here. 9 will go in 36 again, 4, because 9 times 4 is 36. 9 times 6 is 54, so 9 will go there 6 times. 4 can still do its magic here. 4 in here, 1. And 4 can go into 80. How many times? 20 times, right?
Yes.
Okay, so this makes things easier for us. We're now left with 20 times 6, which is 120. 120 what? White cards. So let's just, I'm not going to write it all in full, but I'll just write 120 whites. Okay. So we move on to the next question. It says, there are 50 gray cards in the pack. Now remember, only 2 colors are defined. The rest fall under other colors. So including gray. Let's see the story they're telling us here. It says there are 50 gray cars in the park. A car in the car park is picked at random. Find the probability that this car is gray. Now, you remember the formula for probability. The formula for probability is number of required events over number of possible events, right? Number of required events. Now, remember, what is our required events? I told you the required events depends on the question. In this case, the question is afterwards, gray. So that's the required event. The probability that the car is gray. That's the required event. So how many gray cars do we have? We are told that there are 50. So just put your 50 there on top. Then number of possible events. All the cards are possible events. So that's 540. So the good thing that we found T. That helped us in both question 1 and question 2. So things can cancel, leaving us with 5/54. Okay, I know you're thinking, should you change the 5/54 to decimal? Well, typically, probabilities are usually found as fractions or decimals. So yes, anyone we do would still be correct. I usually like seeing them as fractions. So I think I'm okay with my answer like this, and you should. It's good. So do you have any questions on this?
No.
Okay. Now, did you notice that they didn't ask you anything about the other colors except gray? Well, and that one was even probability. But let's say there was a question, about what's the possibility of the remaining numbers of the other colors. Then you would have had to work out, you may have, sorry, excuse me, you may have had to work out the remaining angle for other colors, okay? Had they been, they didn't ask for white, and they just said, what's the number of other colors of cards, then you'd have had to work it out. And to work it out is to simply say, subtract the sum of 90 and 80 from 360. That's all. But this calculation is the same thing you would have done. You would have first of all found T. Then you now say whatever answer you got divided by 360 times T. That will give you the number of other colors. Okay. Did you get the explanation?
Yes.
Okay. I usually like to answer the question and then, if possible, answer what other possible questions that could come out from that. Can you handle this, or do you want us to do it?
Um.
This one doesn't look like that one that we did in the morning, though. Can you handle this yourself?
Yeah.
Are you sure? So what would you do in this case? You would change all of them to decimals, right? Is that how you would handle it?
Yeah.
Okay. All right. Should work since they allow you to use calculators. Okay. What's the next one? Graph. Can you do this yourself?
Mhm. Yeah.
Okay. All right. How about this one? Yes, this one is the calculator thing. So how about this one? Question 13.
Yeah. That's fine.
Okay, so did you notice that they said give a reason for your answer? So what reason are you going to give for your answer?
Angles on a straight line equal to 180.
Exactly. Perfect. That's the only reason. Okay, transforms. I'm sure you're good with transforms. How about this one? Write 17 as a fraction of 30. Okay, so for this one, it's very simple. 17 as a fraction of 30 is simply 17 divided by 30, nothing else. And nobody is going to ask you to give them the value in decimal. Just leave it like that. That's the answer. Okay, so what I usually do is whatever comes after the off, okay, is denominator. Find itself there. And whatever is in the rest of the question will find itself on top as the numerator. Okay, so that's how I usually handle that fraction of question. Okay. Number 9. Is number 9 something you can do? Alec needs to work out the value of 2 plus 3 times 4. He writes 2 plus 3, 5. 5 times 4, 20. So 2 plus 3 times 4 is 20. It's clear that he's wrong. Can you explain why?
You didn't multiply first.
Exactly. We have to multiply first. And that's based on, so which one would you give them? BODMAS. Are you familiar with BODMAS or
Yeah.
PEMDAS? Which one?
BidMass.
BODMAS, okay. So that's summary of your business. So you just tell them that multiplication should come first before addition. Okay. This one is number 1. This guy comes number 2. Okay. What next? This looks like a graph for probability, but let's see what it says. It says 5 students throw a dice. They each throw the dice the same number of times. And it now says the diagram gives information about the number of times the dice lands on each number, okay? So frequency, 1 happens 6 times. It shows 2, 4 times, 3, 5 times, 4, 8 times, 5, 7 times, and 6, 5 times. It now says, work out how many times each student throws the dice. Okay, so what do you think we will do here to get how many times each student throws the dice? We'll simply add the frequency, isn't it?
Yeah.
That's it. This question is very simple. Just add the frequency. So that's 6 plus 6 plus 4 plus 5. Just trying to be careful because sometimes it's the simple questions that can trip you up if you're not careful. 6 plus 4 plus 5 plus 8 plus 7 and plus 5, right? I think that's the last one. So, and all this will be equal to, sorry, I meant to say, okay. So what would that sum up to? 6 plus 4 is 10. 10 plus 5 is 15. 15 plus 8 is 23. 23 plus 7 is 30. 30 plus 5 is 35. Okay. So did you get that?
Yeah.
Okay, let's move on. Okay, a baker has 3 bags of flour. A, B, and C. Bag A and bag B contain the same amount of flour. So XX or TT or whatever amount, AA, whatever letter we want to use. It says in bag C contains 940 grams of flour. It now says in the 3 bags, there's a total of 2,500 grams of flour. I guess what the question would be, work out the amount of flour in bag A. Simple. So if you were to do this question, right, you would simply use a letter to represent what is in bag A. So if let's simply say, let small letter A be the amount of flour in bag A. Okay. So remember, from this fact here, we are told that bag A and bag B contain the same amount of flour. What does that tell us? It means that if I'm going to find the sum, then I'm going to say 2,000. I think there should be something I can do better with this guy. I can use text for this. That will be faster. So I'm going to say A plus, okay, plus A is going to be equal. Oh, sorry, it's not equal time yet. I have to take care of C. 940 is now equal to 2,500. Okay? Do you understand what I just did back there?
Yeah.
Okay, good. So what does that mean? That means that A plus A is what? 2A, isn't it?
Yes. Oh.
2A plus 940 equals 2,500. Okay, so what do we do next? What happens next after this? What's the next step?
Um, Subtract 940.
Yeah, exactly. Subtract 940. Okay, so let's subtract 940 from both sides. That's going to be 2,500 minus 940. Okay, so what does that give us on your calculator?
Um, 1,560.
1,560 is equal to 2A. So you're looking for A. What are we going to do to both sides?
Divide by 2.
Yes, divide both sides by 2. So, okay. So, so I know you can use your calculator, but maybe we should just use this as practice. 2 in 15 is 7. Remember 1. 2 in 16 is 8. And then 0 leave us with 0. So A would be what? 780 grams. Okay. Okay. So are you good with this question?
Yes.
So let's move on. Here is a list of whole numbers from 21 to 30. Okay. Yeah. From the list, write down a square number. Okay. So if you look at this, do you agree with me that okay, there's a square number here. Which one is that?
Um, 25.
25, correct. I almost said there's no square number until I remember that 25 is part of the picture. So that's it. Yes. 25 is a square number. So it says from the list, write down a multiple of 8. So which one is a multiple of 8?
Um,
Which one is a multiple of 8? So that you would find
24.
in 8 times table. Yes, 24. So 24 is a multiple of 8. Yep. So it's good to go. All right. It says to draw an accurate scale drawing of this rectangle. Use a scale of 1 cm to represent 5 meters. This one should be simple, right? If a scale of 1 cm represents 5 meters, then 35 is 5 times 7. So that means 7 of these small squares will represent it. So if I start drawing from here, that's going to be 1, 2, 3, 4, 5, 6, 7. So that's going to be somewhere here. Do my best to draw that line to make it straight. Okay. Then 5 times 4 is 20. So that means 4 boxes will take care of 20. And then this would also happen here. Then, sorry. Okay. So I guess you can do a better job at this with your ruler, right?
Yeah.
Okay. Okay, so we're all the way at the top. And of course, you can do that first one. 31% as a fraction, that's 31 over 100. 3 meters into centimeters. So what's 3 meters in centimeters? What are we going to use to convert it?
300.
Yes, 300 centimeters. Then what's next? So if you write the following numbers in order of size, starting with the smallest number. So what's the smallest number in this one?
0.1, the second one.
Yes, this one. So this one will come first. 0.12. Yeah. Which one comes next?
0.21.
0.21. Which one comes next?
1.02.
1.02. Finally, 1.20. Okay. All right. M plus M plus M plus M. That's going to be, what's that going to be?
4M.
Exactly, 4M. Okay, please. And you know what would have happened if instead of the plus, you had multiplication, it would have been M raised to power 4, right?
Yes.
Okay. All right. So I think that brings us to the very top of this. So for those questions that you said you can handle, you you will go through them. Would you go through them tonight?
Yeah.
Okay. All right. Okay. So I'm going to save this. The one I sent you in the morning, have you been able to go through it? The annotated one.
Yeah, no, yeah, no.
Okay. Okay. So let me send you this one. Um, I'll save this one and send it to you. Okay. Um, so the thing is, we still have a couple of minutes before we are done. I was just thinking, is there any other Do you have any other question we could just briefly look at?
Yeah, I think I can.
You have one more, or
Yes, yeah.
you can quickly download one more. Okay, all right. Let me quickly save this one first. So are you sending it via WhatsApp?
Yes, yes.
All right. Okay. Let me go to WhatsApp and check. Okay. Downloading now. Okay. All right. So I'm sharing. I've already sent you the annotated one for the one we just completed. So I'm going to share my screen now. Okay. Can you see my screen now?
Yeah.
Okay, good. All right. So this was the year of COVID, I think, 2020. Yeah, 2019 to 2020. So let's see the questions they had back then. All right, let's start with the top first. Let's go all the way down to 24. Okay, I think that's the last question. 29, is it? Okay, perfect. Okay, so yes, 29. Oh, interesting. That's with linear graph. Okay, so I'm sure you can handle this one. Let's see if you remember. It says write down the gradient of the line with equation y equals 2x plus 3. So this depends on your knowledge of mathematical facts. What would you do for this guy? Do you remember you remember that time we were talking about intercept on y-axis? Do you remember?
Yes.
Okay. So I told you that the the general equation for a linear graph or a straight line graph is y equals mx plus c, right?
Yes.
Okay. So the m is the gradient. So what do you think would be the gradient for this guy?
2x.
Just two. It's just the m, not with the x, okay?
Oh, yes,
So,
yes.
so the answer is two. So let me quickly put two there and we'll move on. Okay. What's next? It says each exterior angle of a regular polygon is 15 degrees. It now says work out the number of sides of the polygon. Okay, so I think I made mention of this before you guys traveled. but let me just remind you. It's the mathematical principle here is that the sum of exterior angles for any regular polygon, in fact, not just any polygon at all, the sum will always add up to 360, which is a good thing. It means that we don't have to start remembering different sums for different polygons. So now I know that the sum is 360. All I now need to do is to find out how many sides the polygon has. So imagine one exterior angle is 15 degrees. So what does that tell me? It simply means that 15 times n, since I don't know the number of sides of the polygon, that's 15 plus 15 plus 15, n times, is going to be equal to what? 360. Now, had it been this question was flipped, and they now told us that it's interior angles we are looking for. It's not, this is not what we'll be doing. We'll be doing something different. So let me just finish working this one, then I'll show you how to go about if it were interior angles they asked. So to find 15, what are we going to do to both sides?
Divide by
Find n. Yes,
15.
we're going to divide by what? By 15, isn't it? So
Yeah.
n will be equal to 360 divided by 15. This looks quite simple, like a two-step thing. So I'm not surprised that they gave only 2 marks for the question. But let's see what will happen if it were interior angles that they said. So 15, 360, you can use 5 and break down. 5 in 15 is 3. 5 in 36. We know that 5 times 7 is 35, leaving us with 1. And 5 in 10 is 2. And then you can now do your 3 in itself, 1. 3 in 72 will give you 3 times 2 is 6, leaving you with 1. In 12 is 4. So that's 24. So this polygon has 24 sides. Let me just write down the answer. Okay. So now, what would have happened if it were interior angles we were asked? Well, then we would now have to depend on a different formula. And that formula is this one. Let me see if I can remember it. 2n, there are 2 ways you can write the formula, either 2n minus 4 or n minus 2. Okay. N minus 4. Sum of interior angles of a polygon is given by n minus 2 or 2n minus 4 right angles. Okay, so times 1 of the interior angles. Okay, so this is the whole idea, right? N is the number of sides, still number of sides of the polygon. 2 is just a constant. If you subtract 2 from the number of sides and multiply it by 1 of the interior angles. So if we pretend that this 15 was in the question, but instead of exterior, they told us interior. And probably the question would say something like this. Okay, so let's say the question would say, there are 2 things the question can say. The question is free to say, what is the sum of interior angles? What's the sum of all the interior angles in that polygon? Then all you need to do is to put 15 here and put, okay, so to be realistic, they would have also given us the number of sides to put 24 here. And by the time you substitute that, 24 minus 2 will give you 22. Multiply 22 by 15. Whatever answer you get is the sum. Let me type it here. So you just have it there. Sum of interior angles. Sum of interior angles. Sum of the interior angles. Okay, that's of a regular of sorry, I think I meant to say regular polygon. Okay, okay. All right. So these are the two things the question can say. It will give you the number of sides, and then it will give you the one of the interior angles. Now on the flip side, the question can tell you this bit, the sum of interior angles, and then ask you either for the size of one of the interior angles or ask you for the number of sides that the polygon has. In either case, it will give you enough information to find whatever is asking you. Okay, but then just remember this formula: n minus 2 times the size of one interior angle will give you the sum of interior angles of a regular polygon. Okay, so I think we can move on now. Okay, so this guy says the diagram shows a right angle triangle and a quarter circle. That's a quadrant. Okay, it says the right angle triangle ABC has angle ABC 90 degrees, obviously, and the quarter circle has the center C and radius CB. Okay, it now says work out the area of the quarter circle. Okay, so now what's the formula for the area of a circle? That will give us a hint for the formula for the area of the quarter circle. So do you remember?
Pi r squared.
Yes, pi r squared, correct. So a quarter circle would be 1/4 of pi r squared, or let's see, or pi r squared over 4. I write it like that to make it simple, since it's 1/4 of the total thing. So I don't know, what did they give you as pi in this question, in this paper?
We have a calculator, so
Is
they want
it,
to,
what did you say?
because it's calculator, we can use pi.
Oh, okay, okay, good, good, good. Okay, so pi on your calculator. So the radius is what? Now, did you notice something? The radius was not given to us, so we have to calculate it, right? So can you guess what the radius would be? Let's calculate what the radius would be. So the radius is this place, R, and somehow the radius has the same length as this side of the right angle triangle. So how do we find this side of the right angle triangle? Can you figure that out? It's still Pythagoras theorem you're going to use, isn't it?
Yeah.
Okay, so let's use Pythagoras theorem. Now for Pythagoras theorem, we know that 9 raised to power 2 is equal to r raised to power 2 plus 6 raised to power 2, isn't it? That's 6 squared. Do you agree with it?
Um, yeah.
Okay, so let's make r squared the subject of the formula. So r squared would be on its own, and that will give us, of course, 9 squared minus 6 squared, isn't it?
Yes.
Okay. Furthermore, 9 squared is 81. Okay, so get ready with your calculator. 81 minus 36. What would 81 minus 36 give you? What would 81 minus 36 give you?
45.
45. Okay. All right. So remember, all this while it's been r squared we're dealing with. So for r now, we're going to have square root of what? 45. So what does your calculator say is the square root of 45?
3 and 5.
What did you say?
5.
I didn't hear you back then. Did you say
5.
3.5?
Yeah, 5.
Okay. I didn't hear you, but okay. I just heard 5. Let me see if I can use my own calculator. Okay. Okay. Sorry. Okay. So 45. Okay. Okay. I'm not sure, but I'm going to write what my own calculator says. Just confirm that it's the same thing that you have. 6.0. Let me see. What does it say? Give me a long something. 6.7082, blah, blah, blah. Is that what you got?
Pardon?
Look at the answer I got from my own calculator. I'm going to write it out now. The square root of 45, 6.70. Is that what you got?
Oh, decimal. Sorry.
Yes, yes. And that's because, you can see the question says, give your answer correct to 3 significant figures. So, yeah, it's decimals are allowed. Okay, so now we know what R is. We can now go ahead and put it inside this thing. Now, did you notice something? Ah, I didn't see this on time. All this, at this point, right? We could have even stopped our calculation here. There was no need. Did you notice that?
Oh, yeah.
Yes, because r squared is 45. All we needed to do is to just say pi times 45. You didn't even need to go too far. I wasn't too conscious about that. That wasn't nice. Okay, so well, I guess you can finish it up from here, right?
Yes.
Okay. All right. So just wanted to be sure that's the end of that question. Let's move on. Okay. Okay. Seems to me that number 25. Okay, it's not Pythagoras. This one is different. It's SOHCAHTOA. But let's see which of the SOHCAHTOA they want. It says work out the value of x. All right. So um so if we were to look at this triangle, what is this side to this
Um,
angle? Is it the opposite or adjacent?
Opposite.
It's opposite. So this side is opposite, and this side is the hypotenuse. So I think we're in business. That's so. And so is the first one. So that means sine 34 is equal to sine 34 degrees is equal to the opposite x. That's the one we're looking for, over the hypotenuse 178. So now, have you figured out how to use your calculator to get the values for sine and cosine?
178 multiplied by sin.
Hold on. Let me go back to that place. Yes, so x will be equal to 178 multiplied by sine 34. Okay, so I was asking a question. Have you been able to figure out how to get the value of sine 34? Or to use your calculator to get it? Because right now I'm going to go, or okay, maybe I should just use my scientific calculator. Let's see. And scientific. Okay, let me show you something. I'm going to stop sharing, share my whole screen. I hope your calculator would be something like this. Okay, can you see the calculator on the screen?
Yes.
Okay, so this is what I was telling you that time in the morning. So angles can be degree or radians or grad. So you need to find out on your calculator which one is in place whenever you want to find sine, cosine, or tangent. So I'm going to take it back to degree. So the thing now, or the mode to degree. So now I'm looking for sine. So I'm under my okay, trigonometry. Under my trigonometry functions, I have sine. Let me see. Oh, okay, hold on. Of course, sine 0 is 0. Okay, so let me clear the screen now and put what I need, which is 1, 7. Hold on, hold on. It's not 178 I needed. What I needed is 34. 34. And then I'll now find the sine of 34. Sine 34. Okay, so that's 0.5591. But I've just picked the 4 figures because at least I'm sure of 4 decimal places when we used to use 4-figure tables. So that's 178. Okay, so let's quickly do this. Can you confirm that your calculator would give you the same value? Can you check? Sine 34. Please check it
Yes.
on your calculator. You got the same value?
Yes, yes.
Excellent. Okay, so let me just take this. 5591. 5591. 0, so 0.5591. Or that 5592? Oh, okay, sorry. It's 5592 because of the number after the 1 is greater than 5. Okay, so can you multiply this for me? 178 times 0.5592. So that will give me my value for X before we take it to one decimal place.
99.502.
99.502. And to one decimal place is just going to be what? 99.5. Okay. All right. Okay. Let's move on. So you got it right? Sorry, I think I forgot my units. They might crucify you for not putting units, but anyway, let's put our units so that we're not on the wrong side of the law. Okay, so number 26 is matrices, right? Or yeah, it's a matrix. So 2A, what do you think this is going to give us?
6 and 8.
Yes, 6 and 8, correct. 6 and 8. And 3B is going to be what?
15 and minus 6.
Correct. 15 and minus 6. So therefore 2A minus 3B will give us what? Now that's going to give us, on top you have 6, isn't it?
Yes.
Minus 15. And at the bottom you have 8. Now you have to be careful with that bottom part. 8 minus 6, isn't it? Okay, so 6 minus 15 will give us what?
Minus 9.
Exactly. And finally, 8 minus 6 will translate to 8 plus 6, isn't it?
Yeah.
And that's
14.
going to be 14, correct. So that's it on business. So you just put your minus 9 here, and you put your 14 here, nicely. Okay. Okay, so this is a graph. I'll leave it for you to handle. Carlo puts things into small boxes and into large boxes. He puts 6 things in each small box and 20 things into each large box. Carlo puts a total of 3,000 things into the boxes so that the number of things in small boxes, the ratio of the number of things in small boxes to the ratio of number of things in large boxes is 2:3. It now says, Carlos says that less than 30% of the boxes filled with things are large boxes. Is Carlo correct? You must show all your working. It says less than 30%. For less than 30%, okay, let's see. So, how do we verify this? This one looks a bit tricky. But okay, there's no problem. Less than 30%. Okay, so take a look at this, right? 2:3. So let's establish the number. He puts a total of 3,000 things into the boxes, right? So this is small is to what? Is to large. So let's establish that. Small is to large. So let's establish the number of boxes, the number of things in small boxes, right? So for small boxes, that's going to be 2/5 times 3,000, right? Are you good with that?
Yeah.
Okay. So that will give me 5 and 3,000. That's 600. And 600 times 2 is 1,200. So this is for small. And then for large, that's 3/5 times 3,000. And that's going to give us, if I do the same thing that happened here, that's 600, right? So 3 times 600, that's 1,800. So now the big question here is this: 1,800, because he said something for the large boxes. I think that's what his assumption was on. The number of 30%. He says that less than 30% of the boxes were filled with tins, are large boxes. Is he correct? So let's confirm that. Now, 30% of 3,000 is what? Because that's what we have to verify. 30% of 1,000 is what? That's 30% times, let's say 1,000 times 3,000. So let's quickly cancel things out.
900.
This, you got 900. Okay, good. Perfect. That's 900. So is it true? It's saying that less than 30% of, that's less than 900. Okay. Okay, so now, so let's not mix it up, okay? Let's not mix it up. Remember, it says 30% of the boxes, not 30% of the number of tins. All this, what we're dealing with here, this is number of boxes, right? This is number of boxes, not number of tins. So I think, I'm not too sure if this is what I should be doing. I think I've made a mistake somewhere. It should not be 30% of 3,000. So let me fix the mistake. It should be, it should be, it should be 30% of something else. It should be 30% of the number of boxes. So now, so let's establish the number of boxes. 6 tins in each small box. So we have 1,200 tins in small boxes, right? So if we divide 1,200 by 6, that will tell us how many small boxes there are. So number of small boxes, SB, will be 1,200 divided by 6. That's 200, isn't it?
Yes.
Okay. The number of large boxes will be 1,800 divided by 20. And that's going to be 90. Okay. So that means altogether, we have 290 boxes. Okay. So if I were to be sure of this, 30% of the boxes filled with tin says less than 30%. 30% of 290. Okay, so let's quickly do this, right? 3 times 29 will give us what, please? Less than 30% of the boxes. Filled with things. What 3 times 29 is what, please?
Pardon?
3 times 29 will give us what?
77. No, 87.
87. Okay. So this is 30% of the total number of boxes. This is the total. So is it true that the number of large boxes is less than 87? From our calculations, this is the number of large boxes, isn't it? Clearly, this is not less than this. So Carlo is wrong. Okay, did you get that?
Yeah.
Now, let me ask you this question. Is there another way you could have gone about solving this question? Because I didn't see an avenue to be able to figure this out except this through this avenue. Is there another way you could have attempted to solve this question?
I think that is how I would do it as well.
Okay. Okay. All right. So, well, let me move on. Okay, so this one has to do with sets, and you have a universal set, natural numbers from 1 to 10. A is even numbers, B is factors of 10, and it now says it complete the Venn diagram for this information. Okay, so even numbers, we know that's 2. Okay, so I have to be careful now because some fall into the middle side where it intersects. Okay, so sorry, I didn't erase it. I chose the eraser and didn't use it. Okay, so quickly. So 2 should be here because, somehow it's an even number and it's a factor of 10. 4 is not a factor of 10, so it's on its own in even numbers. Is 6 a factor of 10? Nope. It's on its own in even numbers. Is 8 a factor of 10? Nope. It's under even numbers. But 10 is a factor of itself. So yes, 10 should fall in here, right?
Yes.
Okay, now, can we also agree that 1 is a factor of 10? So 1 should be in here. But 1 is not an even number, sorry. So sorry, that's my bad. Let me take that out. 1 is not an even number. So 1 should be here as a factor of 10. Okay. Then 5 should also be here, right? I think that's
Yeah.
all. Is there any other thing that I left out? Okay, so we've established for factors of 10, 1, 2, 5, and 10. Okay, so let's fill the rest of this shape with the remaining numbers. I can see that 3 is not in the picture. I can see that 7 is not in the picture. And I can see that 9 is not in the picture. So I think it's complete now. Can you check? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's complete, isn't it?
Yes.
Okay. So it now says, probability is usually sister task to set. It now says a number is chosen at random from the universal set E. Okay. And it says find the probability that this number is in the set A intersection B. Now you see that if we hadn't done this, we won't be able to answer this question, A intersection B. So, of course, you remember the formula for probability. is number of required events over number of possible events. The required events is A intersection B. And A intersection B has how many numbers? 1, 2. So you just put 2 there on top. Number of possible events, all of them could have, been possible, are possible events. So that's 10. Okay, so the answer is going to be 1 over 5. Okay, so you can either say 1 over 5 as your answer or 0.2. Because 1 over 5, if you do 1 over 5 on your calculator, you'll get 0.2. Okay? Okay. So are you good with that?
Yeah.
Okay. All right. Let me see. I am running on a pretty low battery, but let's see if I can run this quickly. It says write 84 as a product of its prime factors. Okay. Its prime factors. Oops, see, I'm not sure I can run. Okay, so I'm sorry, I'll have to, I don't really have much of charge on my battery right now, and I don't have power at the same time. But let me see how far we can go. 84 is 21 times 4. And that's 21 is 3 times 7. And then 4 is 2 raised to power 2. So I think that's it as a product of prime factors. Okay, so I'll leave the LCM thing for you. Let's see. Adam, Linda, and Righties share an amount of money. Okay, I think this one too is something you can do. Pens and pencils are sold in a shop. Okay, I think you can also do number 20, right? Are you there?
Yes.
Okay, I can skip 20, right?
Yes, yeah.
Okay. Okay, this is transforms. I can skip that too. Okay, this one is a reasoning question too. I'm not too sure, but let's see if we can quickly run it. Scott wants to make orange juice. He is going to buy boxes of oranges. There are 24 oranges in each box of oranges. 30 oranges make 2 liters of orange juice. He needs to buy enough oranges to make 8 liters. So that means he needs 120 oranges. Okay, so I can deduct that straight. Oh, excellent. Ah, okay, so did you get that? Did you see what I just did? I could quickly deduct or make a deduction that I need 120 oranges to get 8 liters. Why? Because 2 liters is what would need 30 oranges. So how many 2 liters are there in 8 liters? That's 4, right? So 4 times 30 will give me 120. So 120 oranges would help me to get 8 liters. All right. Do you agree with that?
Yes.
Okay. All right. Okay. So the next question is this. They said, work out the number of boxes of oranges Scott needs to buy. Well, at least we can see he needs 120 oranges, right? And they said there are 24 oranges in each box of oranges. So to find out how many orange boxes they will need. We'll simply divide 120 by what? By 24. Do you agree with that?
Yes.
Okay, so we can quickly use 12 and handle this. 12 in 24 is 2. 12 in 120, that's 10 times. 2 in here is 1, and 2 in 10 is 5. So the answer is 5. You need 5 boxes. Okay. So are you good with this?
Yes, yes.
Okay. Scott also buys 1,260 apples, 280 bananas. Write down the ratio of the number of apples that Scott buys to the number of bananas that he buys. Okay, that's simple, right? All you need to do is to say number of apples, 1,260, uh, the ratio to 280. I think this is more of division kind of things. And they said you should give it in its simplest form. So they're just testing your ability. What would you use to break down 1,260? And what would you use to break down 280? Well, what number comes to mind? Hello? Are you there?
Yes, hello.
Yeah. What number comes to mind? You want to break down 1,260 and you want to break down 280. What number would you use to break it down? Because you need to give it in its simplest form.
Do I have to use a big number first, or can I just
Okay,
divide it by?
you could you could use a big number.
Divide it. Excuse me.
Okay, hi. Noah, can you hear me now?
Yes, hello.
Okay. So I'm going to enable you to share your screen. I don't know if you can. My laptop ran out of power. So let's see. Maybe.
I'm on my mum's laptop. So
Okay. So you can share your screen too, right?
no, like I don't have the paper because I can't airdrop it to I can't send it to the laptop.
Uh, okay. 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 Do you want to do that now?
No, like it doesn't, I can't do it.
Okay. Her laptop is not compatible with your device.
Yeah.
Oh, I see. Okay. Okay. I was just thinking that maybe we could work something out. If you send it, can you send it to her mail? Is this something you can do?
Let me try.
Okay.
Yeah, it's not working.
Okay. I don't know what.
Yes.
How is it going?
Yes. Not working, but I did the question.
Okay, which one?
Wait, let me find the number. 17.
Okay, I was thinking that you wanted to send the question to your mom's email so that we could, get it onto her computer. Then you could now share your screen.
Oh no, no, it's fine. I can finish the rest of the people.
Okay, okay, all right. Okay, that's fine then. Okay, so if I can, I don't have power on my laptop right now. I'm using my phone. So if I can, I'll later send the annotated one that we just worked on before um I ran out of power. I'll
Oh,
send it to you on WhatsApp.
okay.
Yeah, probably you can take a look at it either tonight or tomorrow. I don't know when you'll be writing the exam, but yeah. Okay. So I guess you can have a good night rest
Thank you.
and wish you success in the exam tomorrow too.
Thank you.
Okay. All right.
Yeah, bye.
Bye.